As we continue along, we want to begin to simplify trig expressions and verify that two sides of an equation are equal. So in order to do this, we're going to need to have our trig identities that we looked at back a couple of sections ago. And if you have your notes, they'd be at the bottom of page 53. Here was our summary of all the identities: reciprocal, quotient, and Pythagorean identities. Our goal in this section is to take these identities here, and we're going to plug them into an equation in order to simplify. So what we want to do is we want to get the left-hand side equal to the right-hand side and the right-hand equal to the left-hand side. So our big hint here as we do this is we want to get everything in terms of sine and cosine and only work with one side at a time. This is not solving an algebraic equation. So I cannot move stuff from the left to the right, subtracting stuff from both sides or dividing stuff on both sides. I can only work on either the left side or the right side and do that for the entire problem. And a big hint here is when we work with one side at a time, we want to use the more complex side. We want to use the more complex side. So get everything in terms of sine and cosine and use the more complex side. So the first example here, verify that the tangent of theta times the cosine of theta is equal to the sine of theta. I like to draw a nice vertical line here from equals, indicating that I cannot move stuff back and forth. So I look at the more complex side, and the more complex side is tangent of theta times the cosine of theta. And I need to simplify that down to be just the sine of theta. So I look and I see, okay, what is in terms of sine and cosine? Well, I've got sine there, I've got cosine there. That means I have to change tangent into terms of sine and cosine. So I go back to my identities and I look for tangents. And I come across here, tangent of theta is equal to 1 over cotangent. I've got to replace tangent of theta with another quantity. And if I plug in 1 over cotangent of theta right here, 1 over cotangent of theta in place of tangent, that really doesn't help me because nothing's going to cancel out, nothing's going to simplify. So I'm going to continue along here. And right down here, I see another tangent of theta, which is sine of theta over cosine of theta. Since I want to get everything in terms of sine and cosines, this right here is going to be the quantity I want to use. Tangent of theta is the same thing as the sine of theta over the cosine of theta. So I'm going to replace tangent of theta here with sine of theta over the cosine of theta. Now I've got everything in terms of sine and cosine. I can cancel down my cosines, and I'm left with the sine of theta, which is what I wanted on the right-hand side. So that was verification of the first identity. Sine is equal to sine. The second one, cotangent squared of theta equals 1 over sine squared of theta minus 1. I've got to simplify this guy down. And there's a couple of ways that we can look at this. We've got our cotangent squareds on the left and the sine squareds on the right. But we want to ask ourselves which one is more complex. And it's definitely the one that is on the right-hand side. So I'm going to get everything into cotangent squared by my final step. So looking right here, 1 over sine squared of theta minus 1. I've got two different quantities there. So let's start by finding a common denominator. And my common denominator is going to be sine squared of theta. Since I multiply by a sine squared of theta in the denominator over here, I've got to multiply by sine squared of theta in the numerator. And then I can combine into a single fraction. 1 minus sine squared of theta over sine squared of theta. Now I need to find out what can I simplify down in order to get cotangent squared of theta. And if I look back at my cotangent, I see cotangent here is cosine over sine. Which means if I were to follow through by squaring it, cotangent squared, which is what I want, is cosine squared over sine squared. So really in the back of my mind here, I know that cotangent squared of theta is going to be the cosine squared of theta over the sine squared of theta. So I need to get this on the right-hand side. I've already got a sine squared of theta in the denominator, so can I somehow get the numerator equal to cosine squared of theta? Right now I've got 1 minus sine squared of theta. So is there anything with a 1 and a sine squared of theta that I can work with? As I look through my identities, I can see right here, cosine squared of theta plus sine squared of theta is equal to 1. There's the sine squared, and there's the 1 piece. So off to the side here, cosine squared of theta plus sine squared of theta is equal to 1. I need to manipulate this so that I have 1 minus sine squared of theta. And that's easy to do because I can move this sine to the other side. So cosine squared of theta is 1 minus sine squared of theta. I now have my 1 minus sine squared of theta, which is identical to right here. And I can see that's equal to cosine squared of theta. So I'm going to replace this 1 minus sine squared of theta with cosine squared theta. And now I can see that my cotangent was supposed to be cosine squared over sine squared, which is what I've got. So I can finish that off by doing the cotangent squared. The last one right here is verifying this quantity that is being multiplied. And here we've got a binomial. So probably what you're thinking of is foiling out. So let's FOIL this out. Secant of theta times secant of theta is secant squared theta. Secant theta times tangent of theta, or negative tangent of theta, is minus secant theta tangent theta. Multiplying the inside, tangent of theta times secant of theta is a positive tangent of theta secant theta. And then finally the back, tangent of theta times a negative tangent of theta is negative tangent squared theta. As I look at this, the 1 is definitely the more simple side, so I'm going to just work on the left-hand side. Here, since I've got a difference of 2 squares, the middle terms cancel out, so I'm left with secant squared theta minus tangent squared theta. And if I look at that, secant squared theta minus tangent squared theta, haven't I seen something like that before? If I go back to my identities, I can see right here 1 plus tangent squared theta is equal to secant squared theta. So 1 plus tangent squared theta is equal to secant squared theta. I've got to make it secant squared minus tangent squared. So over here I'd have to move the tangent to the other side. So secant squared theta minus tangent squared theta is equal to 1, which is really what I wanted. So secant squared of theta minus tangent squared theta is the same thing as 1. So I've just proved that identity. If I wanted to and I wasn't convinced enough with just this step, I could come down here and rewrite secant and tangent squareds in other terms. Secant squared theta is the same thing as 1 over cosine squared theta. Tangent squared theta is the same thing as sine squared theta over cosine squared theta. If I find a common denominator, which I already have, I can combine my fractions, which is 1 minus the sine squared of theta over the cosine of theta. And as we said right above here, 1 minus sine squared of theta is the same thing as cosine squared of theta. So really this 1 minus sine squared theta is the same thing as the cosine squared theta, which simplifies down to 1. So either verification is perfectly legitimate.